Hi dear student friends, so myself Manjunath RPC, working as a Senior Assistant Professor in the Department of Computer Science and Engineering, Reva Institute of Technology and Management, Yelahanka, Bangalore. So I would like to take this session on functions, arrays and strings in continuation to my with my previous session. So I will take you on this particular concepts. So in the last session we have learned like what is a matrix addition, how it can be performed, with an example how matrix addition can be done, and we have also seen a program wherein we compute the sum of two matrices. Later we also seen the matrix multiplication. So with an example we see how exactly we do the matrix multiplication, and as per the lab program, so we have seen like the input matrices must be read in row major order and the column major order. So we have revisited the way how we supposed to read the matrix elements in row major and column major, and then we have seen an algorithm wherein we compute the product of two matrices. So in this session, we will be learning the matrix multiplication program. So before we go with the matrix multiplication program, we again revisit look into a matrix multiplication algorithm, and then we followed with a concept of strings, and then we see the declaration and initialization of the strings, and then printing a string, how exactly the strings can be printed, and also we will see how exactly we can read a string. So now, this is the lab program. So you have something like you have to read two matrices. So matrix A and matrix B. Matrix A is of order m cross n and matrix B is of order p cross q, and you have to read the matrix A in a row major order, and you have to read the matrix B in column major order, and then you have to compute the product of the matrices, and then you have to display the matrix A, matrix B in the matrix form, and also is supposed to display the resultant matrix, that is product of two matrices, again in the matrix form. So here you should see that. So when you are doing the multiplication, we have seen like the number of columns of the first matrix must be same as number of rows of the second matrix, that is here. So it is m cross n, n is the number of column, so p is the number of rows of the B matrix, so n is the number of columns, so n and p should be equal. So whenever it is not equal, multiplication cannot be done, so you have to display the appropriate message in that case. So the algorithm what you have seen yesterday is like, so first we have to read the order of the matrix A, m cross n, you have to read the order of matrix B, p cross q, then you have to check for the condition whether n is equal to p or not. If n is not equal to p, then multiplication is not possible because of the incompatible matrix order. So you have to display appropriate message stating like incompatible matrix order, so multiplication not possible, and then you have to stop the algorithm. So I mean when you are programming it, you have to stop the program there itself. So otherwise n is equal to p means what? You can perform the multiplication. You have to read the matrix of elements of matrix A, and then you have to read the elements of matrix B. So only thing is here we will be reading the matrix B in column major, whereas you are reading the matrix A in row major order, right? So then after reading the matrix A and matrix B, you have to perform the multiplication. Yesterday we have seen how exactly this code logically computes the product of two matrices here. So now finally you have to print the resultant matrix there, right? Here I have not given the statements for printing the matrix A and matrix B. I am given just the algorithmic statement of printing only the matrix C, which is the product of the two matrices A and B. In the program we will see how exactly we matrix A also, and how exactly we print even matrix B also. Now when you start writing the program, first we should know what are the declarations that we are supposed to do in coding this particular matrix multiplication. So here we must have the matrix A, matrix B, and also we must have the matrix C, and each matrix A is of order m cross n, so matrix B is of order p cross q, and matrix C normally it will be of order m cross q, so that we will see even in the program also. Now initially with the declarations, these are the statements and the variables that are necessary for programming this. So here you can see like m and n represent the order of the matrix A, P and Q represent the order of matrix B, and since matrices are represented using the two-dimensional arrays, I should mention here A of 10 10 represent the maximum order of the matrix what I can have with respect to this. So size what I have mentioned is 10 cross 10. I can have 10 rows and maximum 10 columns. Similarly, I have declared even B also like 10 cross 10. So B is a matrix of order 10 cross 10, a maximum what it can have. Similarly, when I am multiplying the matrix, so here the order of the matrix is C, so that also should be within the 10 cross 10 only. And as the loop iterators, I require some three variables. I am declaring it as I, J and K. Now, so first you have to you have to accept the order of the matrix 1. So, you are reading the matrix A order as m cross n. So, m represent the rows and n represent the column. Then you are supposed to read the order of matrix 2. So, here so P and Q represent rows of the matrix B A and Q represent columns of the matrix B there. So, matrix B means it is matrix 2 in this context. Now, after all reading these particular orders of two matrices, we have to check whether number of columns of the first matrix is it equal to the number of rows of the second matrix, because if it is unequal then we cannot perform the multiplication. So, we check that. So, with the statement if n not equal to P, so that is the column of the matrix A, if it is not equal to the row of the number of rows of the matrix B, then we display a message like multiplication not possible, and then we exit from the program execution, right. So, here instead of if you want, you can say like incompatible message, incompatible order of the matrices, multiplication not possible. So, whatever the message you want you can display here, but display it appropriately, and then you have to exit. This exit is one function, so which will exit the execution of the program. So, whenever you are using the exit, you have to use the associated header file here stdlib.h, right. So, in stdlib.h you can find the prototype of the function exit, prototype or the signature. We will see once the concept of functions, we will get to know that what exactly the prototype mean and what exactly the declaration and the definitions of the functions. So, here whenever we want to exit from the program, so we have to use exit 0. The 0 indicates successful return from the program execution. So, here you have to exit if the matrix order or orders are incompatible. So, if n not equal to P means I cannot perform the multiplication. So, I will be terminating the execution there. Now, here we no need of else part, because in case if this condition fails, so then directly I will go for the normal execution of computing the multiplication of two matrices, and in case if condition is success, that is incompatible order of the matrices are read, then obviously we have to display appropriate message and you have to terminate the execution here, not mandate that I should have the corresponding else statement here. Now, so after having read the matrix order of matrix A and matrix B and confirming that so the multiplication is possible, so when the condition fails here, if n is equal to P, the condition fails, it means that multiplication can be done. So, now we have to read the elements of matrix A and you have to read the elements of matrix B. Now, the code for reading the elements of matrix 1 or the matrix A is, so enter %d elements of matrix 1. Since we have the order of the matrix 1 is m cross n, so obviously in a matrix m into n number of elements must be present in a matrix. So, here we request for enter, so m into n elements of matrix 1, we have to read the elements of the matrix 1. Here m represent number of rows, n represent number of columns. So, m cross n matrix row wise you are going to read the elements here. So, is the reason reading matrix A in row major, so reading matrix 1 in a row major, right. So, as per the question we have to read the matrix A in row major, and after reading the elements of matrix A, you have to go for reading the elements of matrix B. But as per the question, we have to read the matrix B in column major. So, here also, so since the order of the matrix is P cross Q, P into Q number of elements will be present in the matrix. So, before you go for reading the elements, so you display a message appropriately. So, stating like enter P into Q elements of matrix 2, that is the so based on the order, so how many elements are there, you are going to request that enter P into Q elements of matrix 2. Matrix 2 means matrix B, but here you can see like Q is number of columns, P is number of rows. So, here the statement of scanf is like scanf %d ampersand B of Ji. So, here it is A of ij in case of reading A matrix, whereas here it is B of j. This particular change is because we have to read the matrix B in column major order. So, here we are reading the matrix A in row major order, and here we are reading the matrix B in a column major order, right. So, now since C supports row major ordering, so this is quite familiar, because so far some of the programs what we have seen, so we used to this particular way of coding, but here it is bit different only because here we are reading the elements in column major. So, when you are reading the elements in column major, we have to enter appropriately, the column wise the data has to be entered here. So, here I can enter the data in a row major. Now we will see that in the sample output of this program how exactly the input has to be given there. Now after having read the elements of matrix A and matrix B, we are supposed to compute the product of these two matrices. So the code for product of these two matrices is, so for I is equal to 0, I less than m I plus plus, j is equal to 0, j less than q j plus plus, then I initialize here within the j loop. So initially the element value c of I j initialize it as 0, and then for k is equal to 0, k less than and k plus plus, I will performing so those many multiplications, k number of n number of times multiplication, and I add up the products to get the element of c of I j. In the last algorithm and even in the last session, we have seen how exactly we get this particular code in multiplying the two matrices. So here the order of the product matrix will be m cross q. Alright, so here m is the number of rows of the resultant matrix, q is the number of columns of the resultant matrix, that is the product matrix in this case. Alright, so and here number of times we do the multiplication is n. We have to see that in a matrix is m cross n order, B matrix is p cross q order. So there n is equal to p. So that is number of columns of the first matrix is same as number of rows of the second matrix, and those many number of multiplication we supposed to do here. If the n value is 3 there, then you have to do 3 times multiplication, and the product whatever we get, we have to sum all the products and you have to assign to an element of the resultant matrix. Now so here we can see like, so m is the number of rows of the matrix A, and which is also the number of rows of the resultant matrix or the product matrix, and q is number of columns of the matrix B, and which is same as number of columns of the product matrix, and here n is number of columns of the matrix A, which is same as number of rows of the matrix B. So since the number of columns of the matrix A is same as number of rows of the matrix B, we are doing the multiplication, and which is also same as number of multiplication done to compute each element of the matrix C. So for each element of the product matrix, the number of multiplication we are going to do is same as number of columns of the matrix A, which is also same as number of rows of the matrix B, which is the necessary condition to perform the multiplication of two matrices. Now so after performing the multiplication of two matrices, the result is stored in the C matrix. Now your job is to display the result in an appropriate way. So here we display the matrix A elements first, then we are supposed to display the matrix B elements, and finally we have to display the product of above two matrices, something like. So we have to display appropriate message printing the product matrix also. Now so this is the way how exactly I am printing the matrix A here. This is a normal method how you have seen so far in the programs. So reading the matrix elements row wise, and in appropriate columns you are printing the elements there. I is equal to 0, less than m, m is the number of rows of the matrix A, n is the number of columns of the matrix A. So then we are printing the elements of the matrix A, so giving the appropriate spaces there. If you are not leaving the space here in after print of a space percentage d, a space percentage d, then elements will be placed in adjacently. When you are placing the elements in adjacent way, so even if I have entered something like 456, 4, 5 and 6 are the elements of the row, then you display like 456. It will not be visualized at 3 different elements, we visualize it as one single value 456. Say what I mean here is, if I have 4, 5 and 6, the first row elements of some matrix A. So here when displaying, I should display like 4 space 5 space 6 only. If I am not leaving the space between the elements there, so then my display will be like 456. This doesn't mean exactly like I have 3 elements there, 4, 5 and 6. Say for example, in case of 5, if I have 15 there, so what exactly I need to print there? 4, a space, the 15, the next element, and space, then 6, next element. But if you are not leaving the space in the printf statement, what exactly we print? We print something like 4, 15 and 6. We will not get to know here which are the actual elements of the matrix. We may mean like 41 is the first element, 5 is the second element, 6 is the next element, or we can also mean like, so 4 is the first element, 1 is the second element, 56 is the next element. So when you are displaying it, you have to display appropriately, right? See, displaying is like, say for example, if you are a cook and if you have cooked a delicious food, and if you are throwing on the guest will not be happy. Even though your food is very nice, the guest will not be happy. So what you are supposed to do is, so after preparing the food properly, you have to serve to the guest very in a proper way. So only then you get the appreciation there. So here also, though you are computing the matrix multiplication, and when you are printing the matrix, it has to be displayed in a proper appropriate fashion only. So otherwise, so though you compute there, the display does not really mean, so what exactly you are computing there. So here for I is equal to 0, I less than m, I plus plus, you take the row and then you take the column elements, you display it in appropriate way. So whenever you are going for the new row there, you are going to a new line and you are taking a tab space and you are printing it in a appropriate way. Similarly, you have to print the elements of matrix B. Now, so even for printing the elements of matrix B is also same code, except that, so here the number of rows is P, number of columns is Q, and the matrix which you are printing here is B of ij. So reading of the elements was done column wise, column major order, but here when you are printing it, you have to print in normal way only. Column major order is only the method of reading the elements what you have done in this particular coding. Though you are using the column major order there, so in the appropriate memory allocated for the matrix B, you are storing the elements in a appropriate way there. So here the printing of the matrix B can also be done similar to the printing of matrix A. So matrix A is printed, matrix B is printed with this particular code segments. Then after this, you have to print the elements of matrix C. Now, so printing of matrix C is also in a similar fashion. So here you have to display a printf message, product of above two matrices C. Since in the above statements you have printed the matrix elements of matrix A and matrix B, here you display a message like the product of above two matrices C, and then you are printing the elements of the matrix C. When you are printing the elements of the matrix C, what is the order of the matrix C, that is product to be considered here? M cross Q. Fine. So here I is equal to 0, I less than m, I plus plus, then j is equal to 0, j less than q, j plus plus, where q is the number of columns of the resultant matrix, m is the number of rows of the resultant matrix. So you print the resultant matrix in an appropriate way there. So then you return 0 and you terminate the main function. This is the lab program wherein you read the matrix elements. So matrix A in row major order of order m cross n, and you read the matrix B in column major order of order p cross q, and you print the resultant matrix. Okay, so only if the two matrices orders are compatible for the multiplication. If they are incompatible, you are displaying a proper message stating that multiplication cannot be done there. Now, so this is the sample output what we can get. So here they enter order of matrix 1. So here I have entered the matrix A order as 3 cross 2. 3 is the rows and 2 is the column, and then enter order of matrix 1. This is basically matrix 2. It is not 1 there, it has to be 2. Enter order of matrix 2. So here it is a 2 cross 3 there. So then here 3 cross 2 and 2 cross 3. Number of columns of the first matrix is same as number of rows of the second matrix there. So now we can do the multiplication. So since we have 3 cross 2 elements in the matrix, so the order of the matrix is 3 cross 2, we have 6 elements in the matrix 1. So enter 6 elements of matrix 1. So I am entering there 1, 2, 3, 4, 5, 6. This is entered in a row major order. Since it is entered in a row major order, so here we have 3 rows. So sorry, so here 3 cross 2 is the order of the first matrix here. So here we will be having the 1, 2, 3 are the first row elements, 4, 5, 6 are the second row elements. So basically here the matrix A order is it's not basically 3 cross 2, basically it is a 2 cross 3 there, and the order of matrix B is it is a 3 cross 2. So this is number of rows of matrix A, this is number of columns of the matrix A, this is number of rows of the matrix B, and this is number of columns of the matrix B. We can see like number of columns of matrix A is same as number of rows of the matrix B. So here when I am entering the elements there, so I am entering in the way 1, 2, 3, 4, 5, 6. So here these are the elements of matrix A. Since we have 2 rows and 3 columns, in each row we have 3 columns there. So these are corresponding to the elements of the first row, and immediately the next 4 elements correspond to the elements of the second row. So is the reason. So we have here 2 rows and 3 columns. In each row we have 3 elements there. Now if you look at the elements of matrix B, so here we are entering, so like 1, 2, 3, 4, 5, 6 only. Even for the elements of matrix B also we are entering 1, 2, 3, 4, 5 and 6. So here what is the order of the matrix here? 3 cross 2, 3 rows and 2 columns here. Since we have 3 rows here, each row is having how many elements? 2 elements. So it is not like this is the first row elements, this is second row elements, this is third row elements. Normally we mean like it is something like 1, 2, 3, 4, 5, 6. This is not the matrix which you are reading, because here you are reading the matrix in a column major order. Since you are reading the matrix in a column major order, so here how many columns we have? So 2 columns we have, and how many rows we have? 3 rows. So here, so these first particular 3 elements are the first column values, and the next 3 elements are a second column elements. So the basically the matrix what you are reading here is the first column is 1, 2, 3, and the next column what you are reading here is 4, 5 and 6. So this is here 2 rows, 3 columns. Here it is 3 rows and 2 columns. When you are doing the multiplication here, when you perform the multiplication, so what you get here is the order of this matrix is, that is 2 cross 2. So this row you multiply with this particular column, this row is multiplied with this column, you get this particular entry. When you multiply this row with this particular column, you will be getting the second entry. When you take the second row, multiply with the first column, you will be getting the next element, that is the first element of the second row. And when the second row of the A matrix, we are multiplying with the second column of the B matrix, you will getting the fourth element of the matrix. So the computation is done there. So it is like the result what you get here is basically the 14, and then so you get here 32, and here also you get 32, and here you get 77. So here, so in the output what we display here, the only thing you have to note, like in the order of matrix, say it is not 3 cross 2 here, basically it is 2 cross 3, and here the order of matrix 2 it has to be, it is 3 cross 2. So that is a bit modification that is to be done there. Then the remaining the 6 elements are same, and even 1, 2, 3, 4, 5, 6. For both the matrices I am printing the same set of elements, but presentation is quite different here. Matrix A is row major order, so we have 3 rows and 2 rows and 3 columns, whereas in matrix B we have so 3 rows and 2 columns, right. So this is the way how exactly the multiplication will be done. So now, so next we move on to the another concept called the strings. Fine. So you understand the concept of strings the only after knowing the concept of arrays. But before you move on to the strings, so each character in the computer will be associated with certain integer representation. Say for example, so here the A, B, C, these are lowercase letters of the English alphabet. So here the value of A internally, when it is stored in the machine, its value will be stored as 97, B will be stored as 98, C will be stored as 99, and similarly in continuation Z will be stored as 112, that is 112. Similarly for the uppercase letters, we have its own associated integer values. Capital A will be stored as 65, B will be stored as 66, and similarly the capital Z will be stored as 112. So here in continuation, so here it is 112, so here whatever the value you get, that is to be computed there. So now similarly it's not exactly 112 here. So here 26 plus 65, whatever the value we get, that is to be so placed here in place of the ASCII value of the Z here, the integer value associated with the Z. So next, so for the 0, when you are using the integer value 0, the character value, the integer value corresponding to the value 0 is 48. For 1 it is 49, for 2 it is 50. These are basically A, capital lowercase letter A's and uppercase letter A's, and these particular 0, 1, 2, 3 up to 9 number, all these are the symbols, they represent the characters. For each of the character there will be an integer associated with, and here it is a /0, this is, we call it as a null character. The value of null character, the integer value of the null character is 0, and whenever you are printing the new line character /n, so then so that is the ASCII value of that particular /n, the integer value corresponding to that /n is a 10. These particular values we call it as an ASCII values, right. That is, it is an American standard code for information interchange. In every computer the characters will be represented with the respective integer values. It is fixed, like the lowercase letter A is 97, uppercase letter A is 65, and for the character 0 associated integer value is 48. In the program you may read something like integer values, but so when it is stored in the memory, it will not exactly stored in the fashion how we write there. So when it is stored in the memory, the ASCII values of those particular characters will be stored. The numbers will be treated as characters, and those characters will be stored in the memory. In the programming we deal the integer in a different way than that of the characters. So because compared to handling characters, sometimes we feel so convenient and comfortable in handling the integer separately there. But anyhow, for every characters at this this moment we need to understand, like, for every character is associated with its own integer value, which may call it as the ASCII value. So here A value is 97 and lowercase z value is 112, and capital A is 65, B is 66, and so on, and capital Z is not 112. 112 is the ASCII value for lowercase letter z, and this is 65 plus 26, whatever the value you get, that is the value corresponding to this z there. Then here the ASCII value of 0 is 48, 1 is 49, and so on, and the ASCII value of new line character, null character is 0, and ASCII value correspond to the new line character, the enter key when you use. So that enter key, it is the 10, the ASCII value is 10 there. Now characters can be interpreted as integers. In programming also, we can, based on the requirement, the characters can be interpreted as integers. So consider certain statements. So here char C is equal to A. So C is a variable of type char. Since C is declared as a variable of type char, I am assigning a character here. So capital A I am assigning to C. You note that it is within the single quote. If I am not enclosing this with a single quote, I may get a error like the symbol A does not have any valid meaning there, because every variable whichever I am using in my program, that must be declared before I use that. So here it is a single A within a single quote there, fine. So I am assigning A there. When I am assigning A to C, so after doing that, let me use a few statements there. So here print of %C comma C. So here I am printing the value of C, the character C, whatever it is holding, I am printing that value. Since I am storing the capital A in the variable C there, so I am printing the character as A. It prints, this particular printf statement will print the character capital A there. Now if I use another printf statement, printf %D, so then C. So C is a character data, but here I am using the format specifier %D. So in the previous case, here I am using %C for printing the character. So I am storing the capital A in the variable C. So I get the value A over there, right? But here I am printing %D in place instead of a %C. When I am printing the integer value associated with the character, then what happens is, basically C variable is holding what? Capital A. What is the ASCII value of the capital A? If you look into the previous, so here the integer values for capital A is 65. So is the reason. So here, so what we get is, when you are printing the integer value of variable C, since C is holding the capital A, its ASCII value is 65. So it will print the value as 65 there. Now if you look into the another scenario where I am not using the C variable at all. So here what I am doing, printf %C /n comma 65. I am providing the integer value itself here, but here I am printing %C, right? So here the character associated with the integer value 65 will be printed over there, right? So what is the ASCII value of 65? So 65 correspond to which particular character? The 65 is corresponding to the variable, so character capital A there. So this particular statement will print the capital A as the output here. Fine, there is a different way. So only thing is, characters can be interpreted as integers in programming. Say for example, here instead of 65, if I specify 66, what will be the data printed on the screen with respect to this printf statement is like, since 66 is the ASCII value corresponding to the character capital B, so this will print B, it's not a A. Here if it is 65, it will print A, and here if I am changing it to 66, then it may print so capital B over there. So this is the way how exactly characters and integers can be interpreted in programming. Now when you come to the strings, string is not a single character. String is a group of character. So it is a list of characters, but it is exactly not we do not define the strings as just a list of characters. So in a different way it has to be defined. We will see how exactly it has to be defined in a different way. Now first we will see declaring a string. So string can be declared in the form of arrays. Fine. So we have seen an array of integer elements so far, even in the multiplication of matrices, 2-dimensional arrays we have seen, and earlier to that we have even seen the 1-dimensional arrays. So here also we are having a 1-dimensional array. So here A is an array of 5 characters. When I have a group of 5 characters, I may call this as a string, but a string is not defined as an array of character. But there is one more thing which is very important when you are handling with a string. In the later part we will define how exactly it is to be.
Now, so here B is an array of 50 characters. Similarly, name is an array of 100 characters. This is a way how exactly we can declare a string. We can declare like a normal arrays only. Only thing is here the data type should be character when you say it is a string. If it is an integer, then it becomes an integer array. If it is double, then it becomes a double array. But when it is character, instead of calling it as a character array, we call that with a special name called a string. But that's not the definition of a string. Now, when you are how to initialize the string here. So, the initialization can be done at the time of the declaration as follows. So, here we can see like, so char a of 10 is equal to hello here. So, here a is an array of 10 characters, and here I am having the string within a double quote. When I have a character within a single quote, we call that as a character constant. But when I have a sequence of characters within a double quote, we call that as a string. A string is different from that of a character. Within a single quote, if I am mentioning a character, that is a character constant, and the sequence of characters, if I am mentioning within a double quote, then I call that as a string. So, and one more thing here is, if I have just a within a single quote, then this a is a character. It is not a string, because here enclosing this within a single quote. Now, if I have the same a within a double quote, then this is a string. This is a string, whereas this is not a string. This is just a character, right? Similarly, see, if I have something like a b within a double quote, then this is also a string, but I cannot have something like this. This is not a valid character. When I am specifying a character constant, a single character must be kept within a single quote. Escape sequences are exceptional. Escape sequence means basically /n, /t, the characters that begins with the slash, all these are escape sequence. These are also a single characters, though it seems like we are using two characters there, two symbols there. So, one is slash and the other one is a n, but basically they represent a single character. /n represent a enter, is a new line, /t represent a tab space, whereas /a means in the programming, if I use this particular character, when we are executing this particular statement, we get an audible sound, right? We get so alert sound there. So, now, so this is the difference between a single character constant and a string. A string must be enclosed within a double quote, string must be enclosed, character must be enclosed within a single quote. Now, so here, so a of 10 means a is an array of 10 characters, right, since it is an array here, and here within a double quote I am mentioning there the letters what is to be stored in the string. So, that is HELLO. This is one way of initializing the string at the time of their declaration. So, here the first character is H followed by E, to its next is L, again I have L there, and finally I am taken O there. This is one method. The another method is, so a of 2. So, A2 is another array of characters. Here I am not mentioning the size. When I am not mentioning the size, I have to see there. So, how many characters I have taken in the initialization. Here I have HELLO. So, here altogether we have 1, 2, 3, 4, 5, and this is a special character what is to be placed in the string, and this has to be terminated by a semicolon there. So, that is a proper declaration, proper initialization. So, here 1, 2, 3, 4, 5, 6 characters I am storing in the array A2. So, here the size of the array will be computed automatically by the compiler. The size of this particular array is 6 there. So, the size of this the index value what we mentioned, so when you are declaring the arrays, it is 6 over there. But how exact it is stored in the memory? So, when it is an array, the index starts from 0. So, here a of 0 is H, a of 1 is E, a of 2 is L, a of 3 is again L, a of 4 is O there. Fine. So, now we will see that memory representation of that. So, here a of 0 is H, a of 1 is E, a of 2 is L, a of 3 is L, a of 4 is O, and a of 5, this is a new character. So, this is a /0. So, this particular /0 this has to be a backward slash, it is not a forward slash, it has to be backward slash. So, /0, so this is, we call it as a null character. This is null character. Every string must be terminated with a null character. So, if it is not terminated with a null character, then that is just a sequence of character. It will never be called as a string. So, with this we can define a string as, so here we have to note that the end of the string symbol must be a null character there. So, we have to define the string as, so it is an array of characters terminated by a null character. If I am not terminating it by a null character, so then that will not be a string, that will be just an array of characters there. There is the reason why we have to terminate this particular string by a null character. So null characters play a major role when you are handling the strings in the programming. So the string we can define it as it is an array of characters terminated by a null character. Now, so once we see the printing of the string, so you will get to know that how exactly the null character play a major role there. Now, printing a string I can do in two different methods. I can print character by character. So that is a of 0 is first character, a of 1 is second character, a of 2 is third character, and so on. Or I can print the string by making use of the printf function, or I can make use of the putS. So putS is an unformatted output statement, whereas printf is a formatted output statement. Fine. So when you are using this particular printf and printf function for printing the string, or the putS when I am printing the string, I make use of the null character. Always make a note here, like a string means it is an array of characters terminated by a null character. That is the definition. So fine. If it is not terminated by null character, then handling the strings becomes quite difficult. Now, so here the name of an array we use. Normally when you are printing, so we do not use the name of an array, we have to use the index. Here assume if I have A is an array of 5 integer elements. When I am printing the elements of matrix, printing the elements of an array A, so here I use like %d A of 0. Similarly, so I can use printf %d A of 4, the last element. These are the syntax what I normally use for printing the elements of the array. A of 0 refers to first element, A of 1 refers to second element, A of 2 refers to third element, and finally A of 4 refers to the fourth element of the array. But so here I do not use the statement as printf something like %d comma A. So this is not an allowed one, because here A will hold the address of the complete array of integer elements. Fine. But you can see at the strings, when I am dealing with the string here, I may use here the name of the array. This is quite different the way how I handle the array of character from that of the integer elements. Fine. So another way is putS A. So A is the name of the array if I am assuming there. So then putS A is another function, which is a unformatted output statement to print a string. If you look at a program, so you will get to know how exactly it works. Now here I am using one string. str is an array of a character. I am not mentioning the size here. So the size of this particular the array. Here I am using a string called edusat, right? So here how many characters are present in edusat? 1, 2, 3, 4, 5, 6 characters are there. But here the size of str is not 6. You should make a note that size of str is not 6, because there is a special character which must be ended with the which must be used at the end of a string, that is null character. So here null character is also one character. So because of that, the size of str here will be like 1, 2, 3, 4, 5, 6 characters for the edusat characters of the edusat, plus 1 for the null character. So here the size of str, it is automatically computed as a 7, right? So here the size of str is a 7. So now the string str is %s str. So here, so I print the str here. So I am specifying here str. When I am specifying the str, I am providing the address of this str. Say when I use in this particular statement char str equal edusat, like this. So a memory will be allocated for str. Zero, 1, 2, 3, 4, 5, 6. So this is E D U S A T, and there is a special character which will be placed at the end. So this is null character. Fine. So there will be address for each of these. Character will take 1 byte of memory area. So here, so since str is holding here 7 characters, the size of this str will be of 7 bytes. Each character will take 1 byte. Similarly, if I declare int a of 5, So, here what is the size of A here? I am mentioning here size of A as 5 there. So, how much memory is allocated there? Each integer, if it is taking 2 bytes, I am assuming 16-bit machine, then 5 into 2, 10 bytes is the memory what is allocated for A in this case, right. So, whereas in this particular case each character will take 1 byte. So, here 7 bytes of memory will be allocated. If this address is 6500, then 650, so this will be 651, 652, 653, 654, 655 and then 656. So, from 650 to 656 inclusive of 650, 7 bytes of memory will be allocated there. So, now if it is, I am writing here the declaration with 5 and 6. This is I am declaring and initializing at the time of declaration the integer array A. So, there I am using the number of elements as a 0, 1, 2, 3, 4. This is an array A. So, here I am storing the value 5, here I am storing the value 6. This is partially initialized, the remaining elements will get the value as a 0 there. Assume here if the address is starting at 700, then since each integer will take 2 bytes, that block of 2 bytes here starting is at 700, the next byte will be 701 and the next elements start at 702. So, then the next element start at 704, the next element starts at 706, the next element starts at 708. So, up to 700 to 709. So, inclusive of 700, I will be having here 10 bytes of memory area. Each integer will take 2 bytes. So, is the reason 10 bytes of memory is allocated there. But in this case, I am using here 6 characters. One is for the null character. I am allocating here only the 7 bytes of memory area. When I am printing the integer value, so I have to specify this particular value, that address where exactly I need to get the value there. So, say for example, say if I say when I am using the printf statement, I may use the statement as %d comma a of I. So, this when this particular I value is 0, a of 0 means this is the element. Fine. A of 1 means this is the element. A of 2 means this is the value. A of 3 means this is the value. Similarly, A of 4 means this is the value what I will get. But here when I am printing the string, I use the statement as printf %s comma str. So, here I am not using str0, str1, str2, rather I say only this particular address, right. The reason what happens here is from this address it go on printing character one by one. The printf function will go on printing the character one by one. What is the first character here? E. Next character is D. The next character is U. Next character is S. To its next character is A and to its next character is T. And finally, we have this particular character. So, what is that character? A null character. String must be terminated by a null character. When the printf get this null character, it stop printing the characters there. When it has stopped printing the characters there, so what is the string you have displayed there? EduSat, the string which was stored in the str variable array. So, you are printing the same string on the screen there. So, here you are mentioning str, so the name of the array here, whereas in printing the integer, each individual element you have to use there. I cannot use printf %d and then, so here mentioning the just a name of an array will not solve the printing of the array integer array elements. I mean, so if I am using here %d and a, so this will not solve the problem of printing the array elements on the screen. Fine. And here I am using here %s. So, is the reason I am getting this string printed over there. If I am using, in short I am using pf instead of printf. If I am using like this, then again this will not work. %c correspond to single character, whereas %s correspond to the sequence of multiple characters. So, is the reason when I am using %s, I can mention the base address of the array. So, address of this particular array str is starting at 650. This is just an assumption. I am assuming that 650 is the starting address where exactly the string EduSat get stored. Right. So, but here, so address must be specified when I am using %s. If I am using %c, then this may not, this will not work at all. Right. So, here %d correspond to printing of only one character, and here when I am using %c, str I should not give. I have to give there str of 0, str of 1 and all such thing. So, anyhow, so we will get to know in the rest of the code here. Now, the string is the string str is percentages str. Since I am using percentage s here, I am mentioning str there. The string str is, so means I am printing the string in another way, making use of the putS function. So, I told you like the printing can be done in 2 methods. So, basically in 3 methods I can print character by character, or I can print using the printf statement, or I can print using the putS statement. putS is an unformatted printf statement. So, whereas printf is formatted. The reason why we use formatted and unformatted is whatever the data you are printing on the screen, you can format it, making use of a /n, /t and all those stuff. You can format the data and you can use format specifiers there, /n, sorry, %d, %f and all these things correspond to integer, float, all these data, right. So, these are format strings. Since you are using the format string in the printing, you may call this particular function as a formatted output statements. So, say whereas in case of putS, you cannot use %d, %f and all those stuff. So, because of that, we are calling that putS as the unformatted output statement. But when you are using this unformatted output statement to print a string, so here you are displaying a message, the string str is, and then after that, so you are printing putS str. What is there in str? Edusat is the string what you are storing in str. Again, the putS will take just a name of the character array. The name of this character array is str. So, it takes the name of the character array as a parameter and it will display the string whatever it is stored over there. So, here you will be printing edusat over there. And after that, another method of printing the string is character by character. So, here printf the string str is, again I am reprinting the same string now, but I am using now character by character. This makes the difference between %s and %c. So, I is equal to 0, str of I not equal to null character I plus plus. So, here, so you can see like, so in the storage I have told you like this is str of 0, it is E, str of 1 it is D, str of 2 it is U, str of 3 it is S. Similarly, str of 6 is a null character. Fine. When I is equal to 0, you print E. When I is equal to 1, you print D, and this you continue. So, up to I is equal to 5. When I is equal to 5, str of 5 is T, that gets printed over there. And when I becomes 6, it is the last character of the array. When you have reached the last character of the array, you will check a condition there, str of I not equal to null character. But what happens when I is equal to 7? So, we can see like when I is equal to 6. When I is equal to 6, you can see like the str of 6 is equal to the null character. So, you will be coming out of the loop. When you come out of the loop, you have printed there each character one by one. So, now you can feel like using percentages is very convenient and comfortable. So, instead of using %c, taking a loop construct and then repeating so those many number of times. So, this will get the things done in a faster way. So, finally, I return 0 and I terminate the program. So, this is the sample output of this particular code. So, note here again, so I am using the char. It is not an integer data type, it is a character data type because I am using the string here. And one more thing is, so when I am using the unformatted output statement here, putS here, sometimes you may need to use here conio.h, conio.console input output header. So, here we are using stdio.h, you may need to use sometimes. So, for putS function you may use here conio.h, conio.h. Now, this is sample output. The string str is the first edusat what is getting printed their string, it is printed through the printf statement using the %s, whereas string str the second edusat what is getting printed over there, this is printed through the unformatted output statement, that is the putS function. And finally, the string str is edusat, the last printf statement, it is printing the data. So, using the character by character printing, using the %c one by one each of the character of the string you are going to print over there. So, now we will see similarly how to read a string. So far what you have seen how to print a string, now we will see how to read a string. Similarly, so I can use reading the character by character and completely read the string, or I can make use of the scanf function or a getS function. So, scanf function I am specifying here %s, and in case of getS function, so I will just take the name of the character array and I will be reading the string. In the example, you can clarify that. So, here we can see like in the scanf function I am not mentioning the ampersand. This is most important. I am not mentioning the ampersand here in the scanf function normally. So, in this particular code, if it is an integer array, if I want to read these elements, so I I use the scanf function as scanf percentage d comma ampersand of a of I. I use scanf percentage d ampersand of a of I. So, because the scanf function will expect the address here where exactly the element need to be stored. When I use ampersand a of I, assume when I is equal to 0, ampersand of a of 0. What is the address of a of 0th element? 700. So, whatever the data I enter from the keyboard, that will get stored in this memory location. In other words, so a of 0 will get the value whatever I enter. So, the scanf will expect so always the ampersand, the address of the variable, so where exactly the data need to be stored. So, whereas the printf does not, printf will just access that particular location whatever the value is there and it is going to print there, right. So, in the case of scanf we must use the ampersand, but when I am using the reading of a string I do not use the ampersand, because so whenever I am using the string I will be using the name of an array. So, one thing you have to note here, like the value of a which is name of this particular array, it is same as the address of the array, which is also same as address of a of 0. That is, the value of a is also 700, address of this array is also 700, and even the address of the 0th element of this array is also 700. Right. So, this is the thing we should keep in mind when you are using the arrays. The concept of address, what is there, that you will learn once you understand the concept of pointers, right. Anyhow, so using this scanf and getters we can print the strings on, so we can read the strings. Now, so this is the program where exactly I am using the scanf statement to read the strings here. Now, using this str is an array of 50 characters. So, I am declaring two integer variables I and n, and I am using the CLR SCR even in your lab programs also. So, first you have to use the CLR, you have to clear the screen, the previous output whatever it will be there. So, you have to clear that in a fresh new screen, you have to print your results. So, here I am using CLR SCR, then print of enter a string. So, I am using here the getters function. For using the getters function, I just use a function called getters, and I am passing the parameter as a str there. Then after having read the value of str, I print a message here, print of /n/t, the string entered is, so getters percentages comma str. So, here whatever the data I have read to the str array, so via the getters function, so that is using the getters method of reading the string, I will be printing it there. So, next I enter the number of characters in the string. This is the reading the character one by one. When I am reading the character one by one, so since string must be, a string is an array of character terminated by a null character, so I should know the number of characters present and I read the character one by one. So, enter, so after that knowing the number of characters of a string, then enter %d characters of a string. So, one by one. So, enter, if I am mentioning 6 characters are present in a string, then I have to enter the 6 characters one by one. So, after that I will be reading the characters one by one. I is equal to 0, I less than n, I plus plus, scanf %c str of I. When I is equal to 0, I read the first character, 0th character str of 0. When I is equal to 1, I read str of 1, and so on. And finally, this is most important, str of I am assigning it to 0. So, null character, that is, if I am entered 6, the value of number of characters in a string as a 6, then str0 to str of 5, I will read the character and the last character must be a null character, so which I have to place explicitly, only then it will be acting as a string there. So, str of 5 is equal to null character. So, then the string entered is percentages str. If I am not mentioning this null character, then when I use the percentages, then starting from the 0th location of the string, it go on reading the character one by one, and if it does not see the null character, then so we may get something else also there. So, something else get printed on the screen, so which has to be avoided. So, I mentioned that the null character should be placed at the end of every string. Then after that enter a string. Now I am using the scanf function. So, scanf percentages str. Here I am using only one single statement. So, wherein I am reading the complete the string, that is sequence of characters are there. Then I am printing string entered is via the scanf statement is percentages comma str. So, these are the three different ways how I can read a string, and the output of this code will be like, so enter a string via the getters. If I am entering hi, HAI, then the string entered is HAI will be printed over there. For the same string, so when I am when I am supposed to read character one by one, then I have to know the number of characters present in a string. Enter number of characters in the string. It is 3 characters, so I am mentioning here 3. Then enter 3 characters of a string one by one. First I mention h, which will be read into the str of 0th location. Then I am mentioning a, then it will be read into str of 1 location. Then I am entering I, which will be read into str of 2 location. Then str of 3, when I becomes 3, str of 3 will be get the null character. So then, so string entered is high, it will be printed via the printf statement. Then after that, when I am reading a string via the scanf statement, so enter a string, the scanf with this particular function. So I am reading the high in one sequence of, I am so the sequence of characters I will be reading in one shot. So I will not be using character by character. So then after this, I will be printing whatever the string I have read there. So string entered is so high. So this is the way how exactly I can read a string and print a string. And here, so normal method how we use when you are dealing with the strings is a scanf function. So using percentages and str. And we are mentioning here str is the name of an array. When I am mentioning the name of an array, this name of an array will serve the base address of the array there. So since str itself will serve the base address of the array, I no need to mention here ampersand of str. Even if I mention ampersand of str also, it works in the same way without any logical errors. So fine, ampersand of str and str both mean the address, starting base address of the array of 50 characters. So this is the way how I can read a string. So fine. So in the next classes, we will see how exactly certain programs can be executed making use of the concept of strings. Thank you.